Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello, welcome students to TV learning programs. And today I'm going to learn with Senior 4 students economics. And we are still on our Unit 4, which is equations and fractions in economics. Equations and fractions in economics. And our lesson today, I want us to look at what we covered. Then we make a revision on what we covered previously. So I have come with some questions, which I want us to go through together in the 30 minutes. So I have question 1, which says an economic researcher made a study about the consumption expenditure and disposable income of an individual and came up with a linear equation relating the two variables. So we have our linear equation. So our solution, question 1. So we have our linear equation which relates the two variables whereby you have consumption equaling 400,000, then plus 0.5 y plus 0.5y. So this is an equation that we have been given whereby C represents the consumption expenditure and Y represents the consumer's disposable income, the disposable income of the consumer. So this is the linear equation that we have, which relates the two variables, consumption expenditure and the income of the consumer. And you all know that the income of the consumer influences the consumption expenditure. You all know that this one influences consumption. So this is an independent variable, you know that, and this is a dependent variable. So we have our question 1, part A of question 1, whereby they are asking us to find the consumption level of an individual who has a disposable income of 2,000. So they want us to get the consumption level for an individual who has got a disposable income of 2,000 Rwandan francs, How do you go about this? So we have our consumption expenditure, which is equal to 400 plus 0.5 y, of which y is our disposable income. But we have been given the disposable income in this way. So our consumption now will be the 400 plus 0.5. Then the income that we have, you multiply 2,000, because they have given us the income of this individual. So we have 0.5 times 2,000. So what will be our consumption for this person? So this is 400 plus, if you get to 0.5, you multiply 2,000. This 0 may bring out this decimal point. Then you remain with 5 times 200, which is 1,000. So if you get 400 plus 1,000, you will get 1,400 Rwandan francs. So this will be the consumption expenditure for an individual whose income is 2,000. The consumption expenditure for an individual whose income, whose disposable income is 2,000 Rwandan francs. So that is part A. So what is part B of the question? Part B, what would be the disposable income of an individual whose consumption expenditure is 30,000 Rwandan francs? Now, in part B, we have been given C, the consumption expenditure, 30,000 Rwandan francs. So they are asking us to find the disposable income. They are asking us to find the disposable income. So from this linear equation given to you, where C, consumption expenditure, is 400 plus 0.5 income. So in this case, our consumption expenditure is 30,000, which is equal to 400 plus 0.5 Y. So we need this disposable income of this person whose consumption expenditure is 30,000. So in this way now, you will correct like terms together. So 0.5 Y will be equal to 30,000. Then you take away the 400. So our 0.5 Y will be equal to, if you get 30,000, then you take away 400, remain with 29,600. So we can divide by 0.5 such that we get our disposable income. So what will be our Y, which is our disposable income? If you get 29,600 times divided by 5, what do you get? If you get 29,600 divided by 0.5, so you get 59,200. 59,200. So this will be the disposable income for a person whose consumption expenditure is 30. From here, even you can now get the saving, how much was saved. Out of this was spent. So you can easily get the saving. So this is the disposable income, the disposable income for an individual, whose consumption expenditure, whose consumption is 30,000 Rwandan francs. 30,000 Rwandan francs. So that is part B. Then part C, they're asking us if someone does not earn anything, what would be his consumption? Someone who does not earn anything, what would be his consumption? So with part C, if someone does not earn anything, that means his income is 0. His income is 0. You come back to our linear equation where C is 400 plus 0.5 Y. Someone does not earn anything. So that means his income is 0. So what will be his consumption expenditure? So his consumption expenditure, C, will be the 400 plus 0.5. The value of Y, which is our income, is 0 because they have told us that someone does not earn anything. So his income now is 0. So when you substitute here, our consumption expenditure is 400. That will be his consumption expenditure for someone with 0 income. That's why from this equation, this constant, we term it as the consumption at 0 income. This will be consumption at 0 income. 400 is consumption at 0 income. So it just comes this way here. So let's go to our question 2. So that is question 1, which we had. So let's go to question 2. Question 2 reads, an economist came up with an equation relating quantity demanded of a commodity and its price after conducting a study in one of the markets. Which equation did he come up with? The equation is quantity demanded equaling to 800 minus 0.2p. This one, Q stands for quantity demanded of the commodity, then P stands for the price of that commodity. So this is a linear equation that he came up with after conducting his study. So now, let us try to see what they are asking us on this. Part A, how many kilograms of the commodity can one buy when the price of the commodity is 600? So part A, they're asking us quantity demanded of that commodity when the price is 600. So our quantity demanded will be equal to 800 minus 0.2 times the price. We have been given the price when the price is 600. When the price is 600. So our quantity demanded will be, you get 800 minus. Here we have 0.2 times 600. This 0 brings or takes away this decimal point. Then you remain with 2 times 60. 2 times 60 is 120. So our quantity demanded will be, if you get 800, you take away 120, you remain with 680. So this will be our quantity demanded of that commodity when the price of it is 600. When the price of the commodity is 600, the quantity demanded will be 680 kilograms. So that is part A of that question. Then part B, what would be the price of the commodity if the quantity demanded of it is 300 kilograms? In this case, we have been given quantity demanded as 300 kilograms. So what would be now the price level? What would be the price of this commodity when the quantity demanded is 3 kilograms? So you restate the equation that we have here, the quantity demanded equaling to 800 minus 0.2 P, where P is price of the commodity, then Q is the quantity demanded. So we have been given this. So if you have 300 equaling to 800 minus 0.2 P, so we need to solve for this price, and we get the value of P, which will be the price of this commodity. So when you do it in this way, if you bring 800 this side, so you have 300 minus 800, which gives you negative 0.2 P. So here we have negative 500 equaling to negative 0.2 P. You divide both sides by negative 0.2 P. Negative 0.2 P. So what will be our price now? So our price P of the commodity will be, if you get, here it is a negative, and the negative divided by negative is a positive. 500 divided by 0.2, that gives you 2,500 Rwandan francs. 2,100 francs. So that will be the price of the commodity when quantity demanded is 300. So that's part B. Then we can look at part C. If the commodity was provided for free, it was for free now. If it was given for free, what would be the quantity demanded? So if it was given for free, part C, if it was for free, that means price is 0. There was no price charged. Price is what? 0, because it was given for free. Therefore, you restate, you come back to your original linear equation, whereby quantity demanded equaling to 800 minus 0.2. Price is 0, because the commodity was given for free. So quantity demanded now will be 800 minus 0.2 times 0 here. So this will be now at 0 price, quantity demanded, consumed will be 800, as you can see. So this is quantity demanded as 800 kilograms at 0 price. At zero price. So that will be our answer, at 0 price. You can relate it now with this. At 0 income, consumption expenditure is 400. At 0 price, quantity demanded is 800. This is our constant. Then we can go to our question 3. Our question 3, we have a firm has a demand equation of P. A firm has a demand equation of P equaling to 4Q squared, then plus Q minus 2. So the Q represents the output, the quantity of output. Then P represents the price. Now, part A of our question, if this is the demand equation, part A, they are asking us to find the total revenue of the firm. The total revenue function of the firm. We know that total revenue, to get total revenue, you will get price times quantity. This is a formula, price times quantity. So in this case, we have our price here, so where it is 4 q squared plus q minus 2. Then we multiply by quantity. So in this case, our total revenue function, if you get this, you multiply it here, you get 4q cubed plus q times q, you will get q squared. Q times negative 2 minus 2q. So now this is the total revenue function of this firm. This is our total revenue function. Now, part B, they want the total revenue when its output is 10. So part B, when output, and this output is a Q, when it is equal to 10, what will be the total revenue now? So you look at this total revenue function, then you substitute the value of Q. So in this case, our total revenue here will be 4 into 10 cubed plus 10 squared, then minus 2 times 10. So in this case, 10 cubed is 1,000. Then 1,000 times 4, you get 4,000. Plus 10 squared, that is 100. 10 squared is 100. Then minus 20. So you can simplify this. If you get 4,000 plus that one, you get 4,100 minus 20. So what do you get? What is the revenue here? If you get 4,000 minus 4,100 minus 20, what do you get? You get 3,000. You get 3,980. 3,980. So you can try to check. If you get 4,100 minus 20, see if we get the right figure. We get 0. Then here we get 8. Here we have 0, 10. So we get 8. Then we get 3. 0 minus 0, 0. 0 minus 2, impossible. So 10 minus 2, 8. Here we have 0, so 10. We have 10 minus 0. Here we have 0 here. 0 minus 0, 0. 0 minus 2, impossible. So you borrow 1 here, it becomes 10. 10 minus 2, you get 8. Then here we have 0. We have 0. Then here we have 4. We have 4. We have 4. So it is 4,000. It is 4,800. 4,080. 4,080. So it is 4,080. 100 francs. 4,080. So that is our total revenue. 4,080. So part C, the marginal revenue function of the firm. Part C, the marginal revenue function of the firm. So how can we get the marginal revenue now? So the marginal revenue function, we shall differentiate. Now this is the application of derivatives. So we differentiate the total revenue function with respect to output. So therefore, the marginal revenue function, that will be the Q, which is our output of, we differentiate this function, 4Q cubed plus Q squared minus 2Q. That is what we said. You differentiate the total revenue function. So in this case, our marginal revenue function will be 3 comes here, then you reduce the power by 1. So that will be 12 Q squared plus. When you differentiate this, you get Q, then minus 2. So this is our marginal revenue function, 12 Q squared plus 2Q minus 2. Then, how do you get part D? They want us to get the marginal revenue when output is 20. So when output is 20, so what will be our marginal revenue? Substitute in the marginal revenue function. So this will be, our marginal revenue will be 12 into 20 squared plus 2 times 20, then minus 2. Minus 2. Then from there, our marginal revenue will be, what is 20 squared? 20 squared is 400. So 12 into 400. 20 squared is 400. That is 20 times 20. 20 times 20. Then plus 40. 2 times 20. Then minus 2. So what will be our marginal revenue? If you get 400 times this, that is 48 plus 2 zeros, then plus 40 minus 2. So what is our marginal revenue? You reduce this expression, this equation. Here you can get 4,800, then you add 40, then you subtract 2. So how do you get it? What do you get here? So you get 4838. So that will be our marginal revenue when output is 20. So you must remember that to get marginal revenue, you differentiate or you find the derivative of total revenue function. Total revenue function. Then we can go to question 4. We can go to question 4. We can go to question 4, whereby we have in a local market, when price of beef is 2,000 per kilogram, a consumer buys only 3 kilograms. A consumer buys 3 kilograms. So we have 3 kilograms. When the price is 2,000, a consumer buys 3 kilograms. Buys 3 kilograms when the price is 2,000. Then he buys 2 kilograms when the price is 2,500. When the price increases to 2,500, then he buys 2 kilograms. So we have to simplify it in this way. Then they want us to represent the consumer's demand curve on the graph. You represent the consumer's demand curve on the graph. So how do you do this now? So you all know, so on the graph we shall plot these ones in terms of x and y coordinates. X and y coordinates. And remember here, when we are plotting, price is plotted along the y-axis and quantity demanded along the x-axis. So you will have to sketch, make a simple sketch. This is our quantity demanded, and this is our price. So here we put the quantity demanded, maybe 1, 2, 3, 4. Then here with the price, we can look for a suitable scale. We can use maybe 1,000, 2,000, 3,000, then 4,000. Then from this, from our scale, you know that from our scale, we can plot 3 kilograms at 2,000 being the price. 3 kilograms were bought at 3,000, which is our price. Then 3 kilograms were bought. So you have to sketch. Then when the price increased to 2,500, quantity demanded reduced, you can see, to 2 kilograms. So you have to, 2,500, it is around here, 2,500. It is around here, so you have to estimate it very well. 3 kilograms, it is with 3,000. So you have to plot it well. 3 kilograms, when price was 2,000, quantity demanded was 3,000. Then, when the price increased to this, quantity demanded reduced. Quantity demanded reduced. When the price increased to 3,000, quantity demanded reduced. Then from there, you can just sketch. So this is your the demand curve. So we have presented our information. We have presented our information on the graph. You can see this is a negative slope. It obeys the law of demand, as you can see. Because as the price increased, quantity demanded reduced. Quantity demanded reduced. Then, so now we can continue with the part B, where they need us to form a linear equation of this demand curve. So, and with this linear equation, you need first calculate the slope. You need to calculate the slope or the gradient, which will be, in this case, change in y over change in x, which will be change in price over change in quantity demanded. So here, you can check, you will get y1, y2 minus y1, then over x2 minus x1. So, and this is our x, y, x, y. So this is x1, y1, x2, y2. So in this case, we shall get 2,500 minus 2,000 over 2 minus our x1, which is 3. So in this case, we shall have 500 here over negative 1. So our slope is negative. As you can see, our slope is negative. That's why our gradient here is a negative. You must get a negative. Then from there, we can try the general equation of a slope in terms of price equaling to the gradient m, which is m, then quantity demanded plus any constant n. So we can use any pair here, either this or this. So if we use any pair here, price being 2,500, equaling to gradient, which we have as negative 500, then times quantity demanded being 2, then plus this n which we are looking for. So 2,500 will be equal to negative 1,000 plus n. So our n, which is a constant, will be 3,500. So this is our constant n. Then from there, you can substitute back in our general equation, whereby price is equal to gradient, of which our gradient, we have it, it is already negative 500, then negative 500, then Q plus our constant, which is 3,500. So as our general equation relating, linear equation relating price of the commodity and its quantity demanded, So thank you very much. Thank you very much for watching and listening. Then we shall pick from there next time.